Hi, today we're going to look at this Ruckus ICX7150-C12P enterprise grade network switch, which is dead. It won't power on. Actually it does, it powers on briefly. You get these lights flash for a second and then it goes out. Now in the previous video I determined to be the power supply that's faulty because it powers up if you attach 48 volts to this DC output here. And the power supply's got some burnt components on the little PCB down here and it's not repairable, so what we're going to do is power this from an external power supply. Now you have to excuse my voice because I've got a really bad head cold. First of all, replacement power supplies are available for these, not the exact original, but you can get one from DigiKey that will fit. I'll put a link down below, but you've got to modify the case to make it fit. What I'm going to do is power it from this external power supply you can see here with an external converter. I'll remove the mains input jack on this and replace it with this barrel jack onto a piece of plastic which I'll hold in with hot melt glue. This unit actually needs 56 volts to work. It'll power up off 48, but you get complaints in this console about low voltage and the power over Ethernet function don't work. So what we're going to do is take this power supply out, fit this boost converter in its place, and then use the external power supply. So first things first, we need to remove the old power supply. To be honest, this is the first step. This cheap boost converter I got off Amazon. Tighten the screws up as the heatsink is loose on it. You can see it's advertised as 300 watts. I suspect that's going to get pretty toasty, so I'll find a creative way of mounting this. But first of all, we need to remove the old power supply unit. Remove that. Remove this plastic screws. There we are. Ow, hurt. That's it. I'll just cut that like that. That comes off. Like that. There's a big thermal pad underneath the power supply. I'm going to keep that. I'm going to keep this cage here and just look at the actual power supply. Oh, that was bang about, woman. Just bear with me a minute. Right, anyway, as I was saying, let's get that out of the way. Just need to remove the faulty power supply. Now the problem is, what's faulty with this is these components here in the feedback circuit. That transistor is shorted, you can't tell what it is. That resistor there is burnt. Again, you can't tell what values they are. What this thing does, when you power it up, it puts out about 70 volts for a brief second and then it shuts down. So in some cases it can actually kill the main board of your switch. So best thing to do is try powering off a bench power supply first, because if the main board's knackered, it's pointless doing this. It's just going to ruin your day. So if I do any modification, make sure the main board works. I mean, it'll complain in the console about low voltage, but as long as it powers up, you know it's going to work. So we will remove this faulty power supply unit. That's going to use these screws here. Now, in the previous video, these switches are actually used by a house builder in the United States. These Wi-Fi certified homes, which is a US government sponsored project, so tend to fit these in large homes, these switches with some power over Ethernet cameras and access Wi-Fi access points. So this thing, that's what it works on. Just need to remove this power supply. No, it has been switched off for a while, so I can just leave it out of there. That's it. And I keep these little thermal pads. And I can remove that as well. The old PSU. Now let's use a light in here as well, as it's a very bad winter's day. So that can go in the e-waste. You can see where I tried to repair it there. I changed these two capacitors and they make any difference. Tried the optocouplers, I suspected that were faulty. but it's actually that transistor there's a dead short, so it isn't getting the right feedback voltage, and then which is causing it to go into overvoltage mode and shut down. But yeah, that's I think what we do is put this boost converter in here, and we need that thermal pad. So my thinking is I'll put that back on there like that with a thermal pad. I don't think it's going to transfer. Actually, no, I don't. Get rid of that. I just don't need that. That'll be insulating, so put that on there like that. Boost converter will sit on there like that. That's my thinking anyway, so I just need to drill some holes. And I'll come back. Just have to excuse me a moment, I'll just keep muting it. Bang about woman next door makes a massive thud on the wall. So here's my talking tube right on the wall. Now these are 2.5mm holes in this thing. I really want 3mm, so I just wonder if I can drill these out bigger without damaging any traces. Looks like I can, so I should get away with that. Right, so I'm going to take a 3.5mm drill bit and put it in the old drill. Excuse me, just make these holes in the power supply a bit bigger. Like so. And get away with drawing those holes bigger. There's no PCB traces there, so now we just need to make an appropriate size hole in. Yeah, that's the way. And this thing. Right, that's the holes drilled. Need to get rid of any burrs on the other side, so we don't want that. Be able to countersink these a little bit as well, I think. There we go. Right, now the next step is to set this boost converter up. So put that in there. This is going to be glued in place with the mains input connector. Now it's a small screwdriver. Sure they get the input and the right output the right way around. There we are. I haven't tried this boost converter, so I hope it does bloody work. Which one's positive and negative? In positive there, that one. Aye, right, okay. Getting somewhere with this piece of shit now. Yeah, it does work. It's the controls are reversed. It's a lot of adjusting. It's just very, all of a sudden it will go. Controls, you got to adjust it really. So it's at one end. So you have to adjust it, the resistor all the way to the other end, and it'll work. So I'm over turning that very, very tiny amount, and it's adjusting the massive voltage massively. So all the adjustment is at one end of the pot's range. Now, some forums have said it's 54 volts and some it's 56 volts, so I'm going to set this at 54.6. And then we'll see if that works. I assume that will be maximum current, because if that's going to be the current, that's going to have to be wound all the way out to turn the current up to full. Right, with that pot turned all the way to the other end, instead of wound all the way in, I've wound it all the way out, so to turn up the maximum current. What we need to do now is fit it inside the case. going to mount it upside down like that. So place that back on there like that. And then just put some holes through the. I'll fit neatly in the middle. Trim a bit more off. There we go. Then place these two on top of the heat sinks like that. Like so. Yeah, see, they stick out. The bench connector's going to come out, so what I can do is just get rid of this thing that's in the way. I need to remove the bench connector now. Easier said than done. Push out with these tabs here, that's it. Come on. Now, I presume black was the negative. Let's get the original power supply. Of course, it's not marked up, is it? Of course, it's not. Oh, it is. There we are. Yes, it is. So white's positive, black's negative. Right. So I can safely probably have to disconnect that actually and just solder the wires dead over to that. Yeah, let's do that. So just cut this connector off. Right, so for testing we're just going to use this electrical connector block for now. What I'll do in the final version is I will solder these off together, and then in fact I might just solder it together now actually. No it won't. So I need to do just use this connector block for now for testing, and I'll solder it up later. There we go. Tune for maximum smoke. There we go. It's alive once more. Well, these take a long time to boot, so what I'm going to do is just leave it 5 minutes or so for it to boot. I'll shut it down so I don't corrupt the firmware. Monitor that, make sure it's not getting too hot. Everything seems just fine. I'll even put that back over it as well. Yeah, I think I've actually will put that back over it. But yeah, that's just hot metal glue that in place at the back, and then we'll finish off the video. Right, just one more thing. I need to check the onboard voltage, make sure it's still the correct voltage. Right. We're putting some power over Ethernet devices on it. You see it's dropped to 47 volts. That's going to be a problem because the power supply, that will cause a problem on the console. So I might need to set it to 56 volts. It's dropping on load, is that? Right, so current, is it? That's not making any difference. Maybe it's the current limit. Right, okay. Why is it showing negative? Oh, there you go. Oh, here's the current limit. Current limit has to be turned all the way down. So the voltage adjustment thing on this is back to front. So you wind it all the way down to set maximum current, wind it all the way up to set maximum voltage. Makes absolutely no sense. Right, okay, that's the power supply in. Just put this somewhere. So I'm going to stop that up, and then we'll get the top cover on. And I'll hot back glue that connector in place so it won't come out. And that job's a good one. And then we'll finish off the video. Right, well, hot melt glue won't stick that, so what I'm going to have to do is put a little screw in, like that. Put a little screw through there to hold it in place. Can't push through the other side because there's 2 screws, so I'll do that. There we go. That's the back panel that's been modified. You know, if I've put the screw in there because the hot melt glue wouldn't stick that in place, so I just put a screw in with a self tapper. And that completes this repair. Just need to put the top cover on now. And then it's done. Carefully slide that in there. So it's very tricky to get in. It says. That's catching on that. Shouldn't do that. That plastic's going to have to come out because it won't, it catches on the greasy. Bloody screw preventing the case from going on. Yeah. Right, okay, well that's not complete yet then, is it? Yeah, what we'll do is use a countersunk screw instead off the power supply. Screw it in place with a nut instead, and back instead of a self tapper, like so. Tighten that up, wires. Can't bother trying to find the socket set, so that's better. Screws lined up now. So we need to find that screw that I lost earlier. Right, that's how you convert a Ruckus switch into 24 volts. Sorry, 48 volts. Final testing. Plug in. Switch on. And off it goes. There we go. Just give that chance to boot up. I'd say that is a successful repair. Need to plug some power over Ethernet devices into it now to see if it powers up. Right, that switch is booted up. Now let's test some power over Ethernet devices. This manky old CCTV camera. Put it into a pot. See what happens. Power's come on. You see it's working. Yep, that is fixed. Power Ethernet works, everything. And that's how you turn cheap repair for a Ruckus switch. Thanks for watching.